This is a quick summary of this talk. Here it is. And about Bert Belder, he actually sort of writes a lot of the code for libuv, the event loop, and he's explaining the event loop. And it's an interesting talk because he goes on to sort of say that when he was looking for Google images to explain the event loop, he found lots and lots of really great images, but they were all wrong. And so he really basically summarized, this is the event loop. We have phases, and we've seen this before in other videos, of set timeout interview, magical workers done by Node deep down, IO processes, set immediate. If there are no more events to be handled, it closes. And we can see that here. That keeps a reference of all the set times out and all the different tasks, and when it's 0, it exits. But one important thing to see is that although we have the event loop here, within each phase, the micro task and any promises are executed before going on. It's not like process.nextTick is done at the completion or at the very end. It's done in every phase. And we're going to look at some code here that'll prove that. That we've got, for example, set immediate and set timeout. We've got a promise and we've got process.nextTicks in each of them. There'll be a link to the gist for this. And when we run this code, which we can actually do now, if we come in here, and run it, and we'll open up this big and run it, we'll sort of see that in each of the phases, the next ticks and the promises get resolved within each of the phases themselves rather than being queued at the end. So just to remind ourselves of the code, we have set immediate, and here we see how the promises and the processes are resolved within each of this particular phase, and the same in set timeout. Set timeout should occur before set immediate according to the flowchart. The difference is once the loop started and the timers have gone off, it's already moved on. So it's come down here to the set immediate, then it's gone round again to do the set timeout. So it's just a timing issue because it's the loop just starting up. So as we can see here, we have our timers, phase, pending, callbacks, idle, prepare, IO, check, close. But within each of these, all promises and process.nextTicks are running there. And so that's basically the sort of idea that we've got two loops within each event loop. And if we look at the Node.js documentation, we can see that process.nextTick fires immediately in on the same phase. And it also explains that the names are somewhat contradictory because process.nextTick fires immediately and set immediate works later. But it's an old artifact of the past, and to change it would cause too many problems. So in some sense they're misnomers because set immediate is not immediate, whereas process.nextTick is. So this is the talk. It's highly recommended. It's very humorous for him to explain it, and he does work on it. And the only other thing I would like to point out now is that in our code we can actually have a look at the lib. I'll put the links down below, the core. And at line 369, if we come down here in this reference, this is in libuv, which is the event loop. Without really knowing C, we can see that we have our event loop here. And it says update time for the counter, run timers, run pending, run idle, run prepare. So in a sense, we can even see in the code up top here that in the libuv Unix core.c, that's how the event loop works. So if you're ever asked about the event loop, you can say it consists of phases. We've seen this in other videos. And within that, all process.nextTicks and all promises are resolved in here. And when we look later at the event.js call stack and event loop, we will see that there's a special queue for callbacks and a special queue for microtasks, which is things like promises and the mutation observer API that gets priority over callbacks like set timeout and set interval. So a quick little video to summarize this. The links will be below, and it's a great way to answer any interview questions about the event loop.